We proceed to parametric equations. So if we say parametric equations, these are equations defined as a group of quantities as a function of one or more independent variables called the parameters. So usually yung mga parametric equations, when it comes to application, ginagamit sila sa, in your physics, the kinematics. So for example, for kinematics, for example, while a particle is moving along x, okay, with respect to time, so that is, we have dx over dt. So, the change in position along x with respect to time, that is the same as your velocity along x. So that is for the velocity. Then, if we are to determine the derivative of the velocity along x, again, with respect to time, this is your acceleration with respect to x. So usually we have this x as a function of time. Okay, the first derivative of that function with respect to time, that will be the velocity along x. Then second derivative, that will be the acceleration along x. So let's have an example. Okay, so maybe you are able to encounter this type of problem from your physics, but physics calculus based. So a balloon is rising vertically over point A on the ground at the rate of 15 feet per second. So point B is on the same ground level and 30 feet from point A. When the balloon is 40 feet from A, at what rate is its distance from point B changing? So again, don't forget our 5 steps in solving worded problem when it comes to differential calculus. So first, identify what are the given. So we have, initially we have point A. So above point A, we have a balloon that is rising. So let's say this is along Y. So you have the balloon that is rising at the rate, since this is vertical, let's say dy over dx, that is the dy over dt. That is 15, or the same as, you can tell that this is the same as the velocity along y, which is equal to, we have 15 feet per second. So we have another point B on the same level ground from, which is 30 feet from point A. So let's say from point A, we have a distance of 30 feet. Let's say this is, we have point B. So when the balloon is 40 feet from A, so you'll set the distance from point A to the balloon. Let's say this is y is equal to 40 feet. What rate is its distance from point B changing? So we are looking for the rate of change between the balloon, and point B. So let's say this variable is z, y, and let's say this is x, which is equal to 30 feet. Let's say this distance is x equal to 30. So those are the given. So we are, since as the balloon rises, the distance between the balloon and point B will be increasing. So nag-i-increase yung distance nila habang tumataas yung balloon. So we are looking, sa second step na tayo, after determining the given, what are the required. So let's say the distance between B and the balloon is z, that is dz over dt. So gaano kabilis magbago yung distance between the balloon and point B. So that is the required. So after what is required, the next one is we are to set up our equation. For the equation, as you can see, we are forming a right triangle. So by Pythagorean theorem, that is z squared is equal to x squared plus y squared. So you have, as you can see, As the balloon rises, the distance between point A and point B will not change. 30 feet pa rin ito, baby. So 30 feet pa rin yan, hindi yan magbabago. Ang nag-change lang is Y and Z. So therefore, X is constant, Z is variable, Y is variable. So we have perform differentiation, or it's the same as Z squared is equal to 30 squared plus Y squared. We have Z squared is equal to 900 plus Y squared. So, tapos na yung equation. After the equation, we differentiate. This is the same. Differentiate both sides of the equation with respect to time. So, differentiation, this is 2z dz over dt is equal to, okay, this is a constant, 0. Hindi magbabago yung distance na yan. So, that is a constant plus, we have this is 2y dy over, okay, dt. So, we'll be having the value of dz over dt. We may cancel yung 2. Will be the same as y over z dy over dt. Okay, so what's the value of z? We can have the value of z by Pythagorean theorem. This is z squared is equal to x squared plus y squared. The value of z squared is equal to, this is 30 squared plus 40 squared. So obviously the value of z will be equal to, we have, okay, 50 feet. So by substitution, last part, this is dz over dt is not equal to, what is the value of y? That is, we have 40 divided by, what is the value of z? That is 50. What is the value of dy over dt? That is 15. So let us compute what will be the value of dz over dt. So this is the same as 4 over 5 of 12. So 4 times 15 is 60, over 5 is 4 over 5, 12 yan. 40 over 50, 4 over 5 of 12 is 12. 4 over 5 of 15 is 12. This is 12 unit feet per second. Okay? So therefore, habang tumataas yung balloon at 15 feet per second, lumalayo yung balloon from point B at the rate of 12 feet per second. Okay, that is our example. Okay, so another example for parametric equation. So an object moves along a path whose parametric equations are, we have y is equal to 2t squared and x equal to t cubed. So where x and y are in meters and t in seconds. So compute the velocity and acceleration at time is equal to 3 seconds. So as you can see, we have a higher degree equation or function. So it means possible that the actual motion of the object is a curved path. Okay, that is a higher degree function, or second degree, this is a third degree. So we are looking for the velocity and acceleration at time is equal to 3 seconds. So if you are looking for the velocity, okay, the actual motion of the object, if you are to consider a very small portion of the curved path, it has a horizontal component, let's say x, and a vertical component, a y. So let's say this is the very small segment of that motion. So let's say we are looking for the actual velocity. That velocity has a horizontal component or x component. Then it has a y component. Let's say this is b sub y. So if you are computing for the actual velocity, the velocity is equal to the square root of velocity along x squared plus the velocity along y squared. So we need to determine the velocity per component along x and along y. So let's have first the equation with respect to x. We have this is x is equal to time cube. Okay, so we differentiate both sides of the equation. So this is the same as dx is equal to, this is 3 times t squared dt. So we have dividing both sides of the equation with dt. Or we can have it as dx. This is dx divided by dt. This is the same as the velocity along x. The change in position along x with respect to time is the velocity along x is now equal to 3 times t squared. So we are to evaluate on the given time, that is at t is equal to 3 seconds. So we have to do is substitute. The velocity along x is now equal to 3 times 3 squared. So we'll be having the velocity along x, so 3 times 3 squared is equal to 27. So according to the problem, x and y are in meters and time is in seconds. So this is the same as meters per second. So that is the velocity along x. Let us determine the velocity along y. So you have y is equal to, you have 2t squared. So differentiating both sides, this is dy is equal to 4 times t by dt. So we'll be having dy over dt is now equal to, dy over dt is equal to 4 times t. So we have at time is equal to 3 seconds. We have dy over dt is the same as the velocity along y is equal to, we have 4 times the given time, this is 3. So we'll be having the velocity along y is equal to 12 meters per second. Okay, so those are the velocities, our components, x component and the y component. So computing for the actual velocity, this is the velocity is equal to the square root of dx. We have 27 squared plus Vy, this is 12 squared. So the velocity at time is equal to 3 seconds. So it's equal to 3 square root of 97 meters per second, or we have 29.55 meters per second. So that is the velocity of the part of the body in 3 meters in time equal to 3 seconds. So how about the acceleration? So basically, from a given function, the first derivative is the velocity. So the second derivative is basically the acceleration. So with respect to x, again, we have that equation. So in the same way, since the path is a curve, so getting a very small segment, again, if you are to take a very small segment of the motion of the track of the motion of the object, that is the same as we have the acceleration of the body. It has a horizontal component and a vertical component, ay. So we are looking for the actual acceleration. Acceleration will be equal to the square root of the acceleration along x squared plus the acceleration along y squared. That is the resultant acceleration. So sabi natin, first derivative is the velocity, second derivative is the acceleration. So we have that is x is equal to 3t cubed. So first derivative is dx is equal to, the equation of x, that is xt cubed. First derivative is 3t squared dt. So that is the first derivative. Second derivative, kunin natin yung derivative of dx is equal to 3, or is 2 times 3 we have 6t. Derivative of t is dt times dt will be, yan. So 2 times 3 is 6t. Derivative of t is dt. So we'll be having d squared of x is equal to 6. This is 6 times t dt squared. So we have d squared x divided by dt squared. This is the same as the second derivative with respect to time. Okay, it's the same as the acceleration along x is equal to 6 times t. So we have the value of time. The value of time, that is at time is equal to 3 seconds. So we have the acceleration along x will be equal to 6 times 3. So we'll be having the acceleration along x will be equal to 18 meters per second squared. So the unit for acceleration. Alright? It will be the acceleration along x. So let us determine the acceleration along y. Okay, so we have initial equation, or is the position equation, we have y is equal to 2t squared. What is our first derivative? This is dy is equal to 4t dt. Okay, that is the equation of the velocity. Second derivative will give us the equation of the acceleration. So this is the derivative of dy is equal to 4 derivative of ts dt times existing dt. We'll be having as d squared is now equal to 4 dt squared. So this is the same as d squared y over dt squared, or basically the second derivative with respect to time. That is the same as the acceleration along y is simply equal to 4. So 4 meters per second squared. So that is already the value of the acceleration, since we don't have a remaining variable. It's already it's already differentiate. So ang naiwan na lang 4. So how to determine the acceleration? We have the acceleration is equal to the square root of ax squared plus ay squared. So the acceleration is equal to the square root of, what is ax? Saan na yan? This is 18 squared plus ay, this is 4 squared. So we have the acceleration is equal to so acceleration is equal to 2 square root of 85 meters per second squared, or this is, we have 18.44 meters per second squared. So is the acceleration at time is equal to 3 seconds. So kung nagtataka kayo bakit 4 na automatically, which means at time is equal to 3 seconds, the acceleration is already constant. Constant equal to 4 since wala na tayong variable remaining in the equation after the second derivative.